Okay, guys, let's jump right into it. So, let's look at an example where our angle doesn't match up to our traditional trig functions. Okay, a climber hangs from a cliff at a 15-degree angle with a tension of 200 newtons on the rope. Let's draw the picture. That's what's going to be the most helpful. We draw a lot of pictures in this class. They don't have to be pretty. We just need to be able to see what's going on. There's my cliff. Here is the rope. That's a much bigger angle than 15 degrees, but I'm just going to exaggerate it so we can see it a little bit easier, okay? And then we have our climber. All right. So, this angle, 15-degree angle. Here's our 15-degree angle. All right, now that I have this image, I want to draw my tension vector. So tension is this way. Okay, pulling up on him, that's what's keeping him up. This angle is 15. Okay, and let me draw this a little bit bigger. Yeah, be better. Okay, so that's 15. Let's call it a tension vector, and its magnitude is 200 newtons. Okay. There is T sub x. Yeah, I'll do capital T. T sub x and T sub y. Okay. Now, do you see how the angle is opposite from tension, and all the times before the angle was opposite from our y component? So tension in the x direction. Let's look at that. So the sine of 15 is going to equal opposite, which is T sub x, divided by the hypotenuse, which is 200 newtons. Let's times both sides by 200 to get T sub x by itself. Okay. That equals T sub x. Okay, so T sub x is 200. Oh, that's interesting. There's no decimal. So those trailing zeros are not significant. So we only have one sig fig there. So 200 times the sine of 15. And so I get 51.7638, but I'm taking one sig fig. My angle has two sig figs, and so my final answer is only going to have one. So I have 50, and my units are newtons in the x direction. Okay, now for the y, we have cosine of 15 is going to equal adjacent, which in this situation is the y component, divided by hypotenuse, times both sides by that 200 newtons. And then we're going to plug it in to our calculator. Okay. And again, one sig fig, right? We have one sig fig, two sig figs, so our final answer is going to have 1. It's 96.592, so I'm going to round it up to 100. Okay, nice. Let's keep going. Okay, so we have this vector, and its x component is 10 meters, its y component is 4. And it's saying we need to find the angle using trig again. Okay. So we know our x and our y, so when we think of SOHCAHTOA tangent is the only one that does not contain the hypotenuse, and we don't know those values. We know the x and the y, but we don't know our hypotenuse, right? Because we have an x component here, and then we have a y component. Our x component will be v sub x is equal to 10 meters, v sub y is equal to 4 meters. And we're solving for theta. Okay? So tangent of the angle is going to equal opposite, which is my 4 meters, divided by adjacent, which is 10. Notice our units would cancel, and that would make sense because these angles, these degrees, they don't have units attached to them. And now we have to do an inverse tangent. So theta would equal tan inverse of 4 divided by 10. Okay, plug that in. Okay, so pay close attention to your calculators, get lots of practice with them, so that when you get to the exams you can work quickly within that time frame. So I'm getting 21.8014, but how many sig figs? Well, 4 only has 1 and 10 only has 1 because there's no decimal place there. So my final answer can only have one significant figure. So we'd have 20 degrees. Okay. Now we're going to use Pythagorean theorem to find the magnitude. Okay, so we're going to find the magnitude of this vector. So we have v sub x squared plus v sub y squared is going to equal v squared, right? A squared plus b squared equals c squared. Okay? And we're solving for this c squared, or this vector component. So let's square both sides, and we end with this vector. The magnitude of this vector is going to equal the square root of v sub x plus v sub y squared. Okay, let's plug in numbers. Okay, so the square root v sub x is equal to 10, and then if I square 10, I get 100. I had 1 sig fig before, and I need 1 sig fig now, so it's going to be 100 without a decimal point. And then I'm going to add that to 4 squared, which is 16. Now, here's something interesting. We only need 1 significant figure, right? But we don't want to round in the middle of the problem. So let's draw a line under our digit that's significant. We're going to still keep the 16 in our calculations, but we recognize that this value here actually only has 1 significant figure. Okay. So now let's add them. So we're going to have 116. We're adding or subtracting, so it's digits after the decimal place. Neither of them have digits after the decimal place, so our answer will not have digits after the decimal place. So we'll have 116. Okay. And so now we'll take the square root of that. And my final answer is 10.7703. I have 3 significant figures here, and so our answer should have 3. So 10.8. And my units would be, well, we have meters, and so that component would be meters as well. Okay, that's the magnitude of that line. Okay, with a displacement of 15 meters in the x and a displacement of negative 9 meters in the y, what is the magnitude and of the displacement and the angle from the starting position? Okay, let's look at this. So 15 positive meters in the x. Okay, so how many do we have there? 10. Okay, so we have 10 marks here, so let's double them up. Let's each make them 2. So we're going to do 2, 4, 6, 8, 10, 12, 14, 15. Okay, so there's x component. We're in what? So it's displacement. Okay. So now we have negative 9 in the y. So 2, 4, 6, 8, 9 in the y. Okay, now we have a resulting vector here. Okay, so the resulting vector, we'll just call it the resultant for now. And we want to figure out this angle, and we want to figure out that magnitude. Remembering that this is displacement with a magnitude of magnitude of 9. The direction would be negative. And then we have magnitude of 15 meters, right? When we say negative, that tells us the direction. We're not looking at the direction right now, we're just looking at magnitude. So it has a magnitude of 9. All right, so angle first. Tangent, theta, opposite over adjacent, so that'll be 9 meters over 15 meters. So theta is going to equal tan inverse of 9 over 15. Done that. .9638. We have 1 sig fig, we have 2 sig fig, so our final answer will have 1. So we have angle of 30 degrees. Okay, now let's go for the magnitude. We'll call that, since this is r, we'll have r sub y and r sub x. Okay, so r sub x squared plus r sub y squared is going to equal r squared, get r by itself. So we will take we'll take the square of both sides. So r is going to equal the square of r sub x squared. So r sub x is 15. Okay, and I get 225. And then 9 squared, so 81. And then we had 0 digits after the decimal place for both of those. So this would be 306. And so then finally we'll take the square root of that. 17.4929. We have 3 significant figures. So 17.5, and these were meters. Okay, so now our next videos are on our next day in class. Good job, guys. Keep up the hard work. You're doing absolutely wonderful.